All right, so for this section today, we're going to talk about how to multiply matrices because it's different than if we were adding and subtracting. In the last section, when we were adding and subtracting them, you just had to like match up the pieces in the matrices. So as long as they had the same dimensions, you can add them, you can subtract them by just taking the quantities from like the corresponding spots, whatever was matching, and you added or subtracted them. Multiplying isn't as straightforward as that. There's a little bit more of a process to it where we have to check the dimensions first. So the matrices, for one thing, don't have to look exactly alike. They don't have to be a 2 by 2 and a 2 by 2. You could have two separate dimensions, and we'll talk about like what needs to be the same so that you know if they can be multiplied or not. But then when you multiply, like I said, it's more of a process because you're going to have to take the elements within a row and take them times the elements within a column, and then you'll end up adding those things together to get your end result. So it's not anything that's going to require to do a lot of hard math. Like as long as you can add and multiply, you should be able to follow the process. You just have to know which elements need to get matched up with which ones. So remember when we talked about matrices and their dimensions, we always go rows by columns. Okay, so if it says the matrix is a 2 by 3, that means it has 2 rows and it has 3 columns. So an example of that would look like this one that I have here. In order to multiply matrices, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. So this is why I said the dimensions don't have to be exactly the same, but specific numbers within the dimensions do have to be the same. So if you're looking at this example down here, if I'm given these are my dimensions 2 by 7 and 7 by 5, what you need to check is that these inside numbers are the same. That tells you if you can multiply them or not. So if those numbers don't match, then you can't multiply the two matrices together. So 2 by 7, 7 by 5, the 7s have to be the same number. What then happens is those numbers on the outside, the 2 and the 5, that tells you what your dimensions of your new matrix are going to be. So when I multiply a matrix that looks like this, one of them has 2 rows and 7 columns, the other one has 7 rows and 5 columns. My end result matrix is going to have 2 rows and 5 columns. So what we're going to do first is take a look at dimensions, and we're just going to decide if we can multiply them, and then figure out what would be the dimensions of my answer. So I'm not asking you to actually multiply here because you don't know what the matrices are. They're just giving you the dimensions. So for number 1, I have a 2 by 3 times a 3 by 4. So like I said, you want to check and make sure that those interior numbers match, which they do. So 3 and 3, so that's okay. So then that means that I take the outside numbers, and those are my new matrix dimensions. So 2 by 4 would be my new answer dimensions of that matrix. Okay, so I want you guys to try 2 and 3. Decide if you can multiply them, because if you can't, you just have to say not possible. But if you can, then I want you to write down what the new dimensions would be for your answer. So for number 2, if you look at those inside numbers, 4 and 3, they don't match, so this one's not possible. Okay, for number 3, 100, 100, those match. So my new answer, my new dimensions would be 8 by 2. Okay, do you guys understand how to do that? That making sense? So I want you guys to do the same thing for the last 4 on that page, if you haven't yet. Decide if they can be multiplied. They just have it written a little bit differently in that they have the capital letter. But you're still looking at these numbers, like 2 by 3 and 3 by 5. So I want you guys to look and see, can you multiply them? So I want a yes or no answer there. And then if you say yes, write the dimensions of your answer after you multiplied them. So number 1, can you multiply them? Yes or no? Yes. What would be the new dimensions? Good. How about number 2? Can we multiply those? No. 3 and 2 don't match. How about number 3? Yep, what would be your new dimensions? Good, 1 by 5. And number 4? No. Okay, so now that you understand how to do that, let's actually get into multiplying matrices so you guys can see how this works. So in a matrix, and I'm just showing you guys a 2 by 2 for reference purposes here, the positions are as follows. So like I said, you have rows and you have columns. Now each number is in both a row and it's in a column. Okay, so this first one here would be considered to be in row 1 and column 1. And then if you move across, so here, this would be row 1, column 2. Then on the bottom, everything has shifted now to the second row, but then you still have the first column and the second column. So you can imagine that as matrices get bigger, so even like a 3 by 3 matrix or a 4 by 4, you're going to have more rows, more columns, more elements that you have to watch. So when you're multiplying matrices, you're always going to take rows from the first matrix times columns in the second matrix. So in this one, I would take 2, 3, that's the first row, times the first column. And what I've told students to do in the past is to circle up the quantities or like the elements that you're trying to multiply together, because you're going to have to do this multiple times. And so it starts to become a process where you are like isolating the terms that you're looking at just so you can kind of keep them straight and keep track. So for this here, this is going to be only in the first, like my first new element. This is not going to give me more than one answer. So what I'm going to do is take 2 times the 4, and then 3 times the 3, and I'm going to add those two things together. Okay, and then what we do is I'm going to keep that same row circled, so I'm still going to use that row 2, 3, but I'm now going to shift over to the second column in the second matrix. So now I have to take that same row 2, 3 times the new column -5, 1, and that's going to be the next element there in the top row. So you're going to have 2 times -5 plus 3 times 1. Okay, now because both of these matrices are 2 by 2s, if we look at our dimensions real quick, the interior numbers match, and so my answer is going to be another 2 by 2 matrix. So when I'm doing this, I should have 2 rows, 2 columns. Well, I have my first row taken care of. I got to get to my next row, and then that's also going to start to fill in the 2 columns that I'm missing. So after I've done that 2, 3, that first row times all the columns in the second matrix, now I have to move on to the bottom row. So now I got to move on to this -1, 0, and I follow the same pattern. So I take it times that first column again. So it's going to be -1 times 4 plus 0 times 3. Then I'm going to take that bottom row, so that -1, 0, and take that times the second column, the -5, 1. So we're going to have -1 times -5, 0 times 1. If you guys just look for a second here, the numbers that are going to stay the same are the numbers from the second matrix. So like 4, 4, 3, 3, those are matching. The -5s are in the same spot, and the 1s are in the same spot. Really all that's changing is the numbers from the first matrix because I'm switching what row I'm looking at. Okay, so you can kind of always know that that pattern is going to be there. Now at this point, to finish it off, you just need to actually do the multiplication and the addition in there. So make sure that you guys multiply the quantities first and then add them together. Follow your order of operations. Okay, so multiplication always comes first before addition. So this first one would be 8 plus 9, which is going to be 17. Going across to the next element off to the right there. It would be negative 10 plus 3, which is negative 7. Shifting down to the bottom, we'd have 4 plus 0. That should be a negative 4, because it should be negative 1 times 4. So that would be negative 4. And then for the last column there, we'd have 5 plus 0, which would be 5. And so that's your end result. Like I said earlier, it's a little bit more of a process in that you have to do rows, columns, rows, columns. But the math right there, that shouldn't be super hard. Like, that's just multiplying and adding things together. As long as you can figure out how to do the correct matchups, then you should be able to get the right answer. Okay, and what I would do too, like if we look at this next one, always check those dimensions first to make sure that you can multiply them. So remember, dimensions go number of rows by the number of columns. So what would be the dimensions of this first matrix in this first problem? How many rows are there? How many columns are there? So this would be a 2 by 3. What's the second matrix dimensions? 2 by 2. Can I multiply these? Why not? Right, this 3 and this 2 have to be the same number, and they're not. So this one's I'm actually not able to do. So there will be some out there that if they say try to multiply these, you may not be able to because the dimensions don't match up like they should. Okay, number 2, we should be able to multiply. It looks exactly like the one that I went through up above with you guys. So I'm going to give you a couple minutes. You go ahead and try to do this one. Use this problem up here that I went through as kind of a guide if you can't remember the order that we did things in. Okay, so I've got mine kind of written out here if you want to just double check and make sure that you matched up the right numbers. So then if I start to simplify here, we'd have 3 plus negative 3. Nope, 3 plus positive 3. 6 plus negative 12. 2 plus 0. And 4 plus 0. So then final answer here, we're going to have 6, negative 6, 2, 4. Okay, if you didn't quite get that, go back through, make sure that yours matches mine. Maybe you just grabbed the wrong row and the wrong column. It can happen. So you just want to make sure that as you're working through this, that you're working slow until you start to really feel confident in what you're doing. And like I said, I would, circle the row that you're working with and circle the column and then go back in and redo it. So you can erase those lines and go back in and recircle up the things that you think you should be pairing up. All right, so number 3, let's take a look at this one. What are the dimensions of the first matrix? Good, this is a 2 by 3. What's the dimensions of the second one? 3 by 2. So is it possible for me to multiply these? So those middle numbers, 3, 3, they match, right? So what are the dimensions of my answer going to be? Good, 2 by 2. So this final matrix is actually going to look like, the final answer is going to look like the one that you just did. And the one that we did up at the top of this page together. All right, so I'll get you guys started here. So we're going to take this first row, so the 0, 1, 2. We're going to take that times the first column, the 2, 0, 3. They've just added on an extra element this time. You're still going to just add on the multiplication of those two terms together. So we're going to take 0 times 2 plus 1 times 0 plus 2 times 3. So all I've done there is I've had to add on an extra element that I had to multiply together. Okay, now what I'm going to do is take that same row, same 0, 1, 2. I'm going to take it times the second column now. The -2, the 5, the 1. So now we have 0 times -2 plus 1 times 5 plus 2 times 1. Okay, I'll give you a couple minutes to try to do the bottom. And then if you want to take a second and simplify, go ahead and do that too. All right, so I went ahead and finished it out up here. Go ahead and match yours to mine. Make sure that they look the same. And again, if you made a mistake, go in, find it, fix it so that your notes are